Okay, good morning and Assalamualaikum to everyone. Today we continue our lesson. The topic is Pythagorean theorem and trigonometric identities. Okay, I want you to mute your speaker and just talk what you want only. What I want you to answer. Okay, I want you to draw a table that contains three columns, which is know, want to know, and learn. When you look at this topic, what you know, you just write down on your paper, and also write your answer in the want to know also. I give you 3 minutes. Okay, enough. I want to volunteer to share your answer, what you know and what you want to know. Any volunteer?
Me.
Yeah,
Hello.
Umaira.
Yeah. I want to answer. Which the no, which I want. Which I know is to solve the integral problem by using trigonometry substitution.
Okay, what you want to know?
And what I want to know about how to evaluate the problem.
Okay. 1% more? Anyone?
I want to
Anyone
try.
can share your answer? Okay.
Okay. I already know about the hypotenuse, the adjacent, the opposition. And today I wish I can know about how to count the rectangle triangle.
Okay, thank you, Norasila. Okay, from your friend answer, I know you all know what we will learn today from this topic. Okay, for objective, you will identify keys to determine whether to use trigonometry substitution or not. Second, you will learn to use proper substitution for integrand and the derivative. And third, solve the integral after the appropriate substitution. Okay, next, the meaning of Pythagorean theorem is the Pythagorean in geometry that in a triangle with one right angle, usually called a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the length of the two sides. For example, the triangle. Next, the meaning of trigonometry identities. In mathematics, trigonometry identities are equalities that involve trigonometry function and are true for every value of the occurring variable where both sides of the equality are defined. Geometrically, these are identities involving certain function of one or more angle. Okay, we start our lesson today.
Okay, for this topic, we will learn on how to find right triangle by using Pythagorean theorem. Okay, if you all wonder about, Pythagorean theorem is used to find length of any side right triangle. This triangle we will be used in questions to find the answer of the integral. Okay, next. Trigonometry identities will be used in the question to define the integral, but not all question must use trigonometry identities. It depends on the question. Okay, trigonometric substitution. At the end of the lesson, students should be able to identify when to use trigonometric substitution, know how to use proper trigonometry in solving problems, answer 4 out of 7 quiz questions correctly online which in by using Kahoot that will be shared later by my friend. Okay, next. We will learn the three basic form of trigonometric expression that we can use in solving trigonometric substitution. Okay, first, a square minus x square we will substitute a sin theta in the integral to solve the equation. And second, a square plus x square we will use x equal to a tangent theta. And third, x square minus a square we will be use x equal to a secant theta. Okay, for your information, if we want to solve the question, it is does not have to be in square root only. If the question does not have a square root, it also we can also use the trigonometry. We also can use trigonometric expression to define the integral. Can you understand?
Okay.
Can you
Yes, madam.
can you hear?
Yes.
Right? Okay, next, how we solve trigonometric substitution problem. Okay, first we have to choose a trigonometric substitution which we want use if whether sine substitution, tangent, or secant substitution. And second, we have to find values of a and the x in order to solve the integral. And third, we have to replace x and the x values with theta and d theta. Fourth, we have to use trigonometric identities to simplify integral. Okay, trigonometric identities is never mind if you not memorize it. We will show you the formula when in answering the question. Okay, next we will use back substitution to put integrated value back in terms of x instead of theta. And next, we have to draw reference triangle to find values in terms of x. If we do not use triangle to find the values, we can't solve the integral. Okay, draw triangle. Draw triangle. We can define the side right triangle can be defined by using Pythagorean theorem. Okay. Lastly, if it's indefinite integral, you have to add c, so that the answer will be incomplete. So the answer will be complete. Okay. Okay. Do you have any question?
No.
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 All right. For this, I will pass to my friend.
Okay, my name is Noaim binti Muhammad Faizal. Okay, I will proceed the lesson just now. Okay, previously you have recalled what is Pythagorean theorem, right? So now I will explain to you how to evaluate indefinite integral by using Pythagorean theorem. So as you can see in this question, this is served in the denominator. So we can simplify it in any reasonable way due to this square root. So how do you tackle this question? Okay, firstly, you have to draw the right angle triangle in order to find the trigonometry. Okay, after you draw the right angle triangle, let's decide which one is the hypotenuse, which one is the adjacent, and which one is the opposite. Okay, if I pointed this side, okay, what is this? Opposite, adjacent, or hypotenuse in this x sides? This is opposite. Okay, this is adjacent, and this will be hypotenuse. Okay, square root of 9 will be 3, and then square root of x squared will be x, and we put the value of denominator square root of 9 minus x squared into the adjacent side. Okay, how do we decide this side become this value 3x 9 minus square root of 9 minus x squared? We use the formula of Pythagorean theorem, which is a squared plus b squared. This is a plus b squared equal to c squared, and then you just substitute the value and you will get the answer. Okay, then what is the value of sine theta and cosine theta if we put the theta at this corner? And then, okay, if you put the sine theta right over here, you will get x over 3 because sine is so opposite over hypotenuse, which is x over 3. And then from this value, sine theta equal to x over 3, you will get the value of x, which is 3 sine theta, 3 sine theta. And then how to find the value of cos theta? If the theta going to be this right over here, theta, cos theta is adjacent over hypotenuse. So this is the value of adjacent, square root of 9 minus x squared over 3. And then you will get the answer. Just move the 3 into this side, 3 cos theta. Okay, then you just substitute this value, these two value into the equation. So let's take the value of ds by using this x equal to 3 sine theta, and then you find the indefinite integral, which is ds equal to 3 cos theta d theta. So it's going to be similar right over here, dx, 1 dx. So just put 3 cos theta d theta over 3 cos theta, because square root of 9 minus x squared will be 3 cos theta. You just integrate this value, 3 cos theta over 3 cos theta is equal to 1. So you will get the answer, integrate of d theta, theta plus c, and you can see here, theta is equal to inverse of sine x over 3 plus c. So how you get inverse of sine ni? You just take the value of theta. You just substitute the value of theta, which is, you can get it from here. You just inverse, you just inverse the value of 3 sine x equal to 3 sine theta, and you get the answer, theta equal to sine inverse of sine x over 3 plus c. Don't forget to put the c because you integrate. Okay. Next. Okay, this is example on how to solve this integral. Okay, you can see right over here, there is square root of 8 minus 2x squared. Okay, you can see this is minus. You have to use x equal to a sine theta. And then second, integral of 1 over cube root of 16 plus x squared. You see there is addition symbol here. You have to use x equal to a tangent theta. And then third, integral of dx equal to 4 square root of 4x squared minus 1. You have to use x equal to a secant theta. Next. Okay. I will explain to you how to apply, how to use the value this previous slide, this trigonometric expression in the integral equation. Now all the integral equation we can use the this expression, but if we see this indefinite integral, which is square root 8 squared minus squared. Okay, let's see. If you see something in general, squared minus squared, we can use the substitution of uh, x x equal to a sine theta, because this is minor right over here, right? So you can simplify the expression into this. You just put out the pi over out of this integral, and then pi integral of 1 over square root of 8 minus 2x squared dx. And then you have to use the trigonometric expression in order to make an integral possible. Okay, simplify the numerator of the equation by using the expression. Okay, you can write 8 minus 2x squared and factor it as 2 times 4 minus x squared. And then uh, you can see now clearly the pattern of uh, 2, 2 squared, which is equal to 4, 2 squared minus x squared. And then you can get the answer of a equal to 2, and then x equal to 2 sine theta. And then let's make the substitution. X is going to be 2 times 2 squared, 2 times 2 squared minus 2 squared sine squared theta, because x, you already substitute the value of x, 2 sine theta, into the equation. Okay, then we factorize it. 2 times 2 squared theta, 1 times 1 minus sine squared theta. 2 times 2 squared theta is equal to 8. Just the same, okay? Okay, then after we get this expression, after we get the factorization, you just substitute the value of 1 minus sine squared theta with the trigonometric identity to simplify the expression, which is, as we know, sine squared theta plus cos squared theta equal to 1. And then we just move the value of sine squared theta into the right position, and you will get 1 minus sine squared theta is equal to cos squared theta. Okay. You see here, the previous slide, just now, 2 times 2 squared times 1 minus sine squared theta, and you substitute the value of cos, the trigonometric identity into the 1 sine squared theta, and you will get this 8 cos squared theta. Now, finally, you just substitute all the value you get, dx equal to 2 cos theta d theta, and square root of 8 cos squared theta into the first expression, into the first equation, which is pi integral of 1 square root 8 minus 2x squared dx equal to pi dx, you just substitute with the value of 2 cos theta d theta, and then the denominator you substitute with this value. Okay, after substitute, you see here how we get 2 times square root of 2, 2 set 2. It is when we find the value of square root of 8 is equal to 2 times set 2. Okay, and then cos theta d theta, because the value of square root of cos squared theta is cos theta. And then you just divide it. 2 divided by 2 is 1. Cos theta divided by cos theta is 1. And you will get the answer pi over sec theta integral of d theta. After you cut it off. And then pi over square root of 2 theta plus c. Okay. And then just substitute the value of theta. Okay, where can we get the value of theta as seen like this? Pi, the final answer is pi over square root of theta sine inverse of sine times x over 2 plus c. Okay, the value of theta, we just take it from the value of x equal to 2 sine theta. You just move the 2 sine to the left side, which is inverse of sine plus inverse of sine times x over 2. Okay, this. Just substitute the value into the theta and we get this final answer, but don't forget to write plus c. Okay. Okay, next. In this section, let's see how to evaluate, how to integrate this expression by using tangent. Why must we use tangent? Because why must we use tangent? Because the symbol of addition. Okay. When we see right over here, there is addition symbol. You just use the trigonometric expression in order to make an integral possible, which is a squared plus x squared, x equal to a tangent theta. Okay, firstly, you write the expression become like this, which is cube root of 16 plus x squared become this, 4 squared. 4 squared is similar to 16 and then plus x squared to the power of 3 over 2. And you will get the a is 4. And transfer the a into this expression, which is x equal to 4 tangent theta, and you find the indefinite integral for secant squared theta d theta. Okay, after that, you substitute the value of x into the denominator. Okay, the value of x is x equal to 4 tangent theta, right? So, you substitute into the denominator. So, it will be 4 tangent theta squared plus 16 to the power of 3 over 2. Okay, then you expand it. 4 squared is 16. Tangent squared theta plus 16 to the power of 3 over 2. Okay, to the power of 3 over 2. And then after you expand, you will get 64 tangent squared theta plus 1 to the power of 3 over 2. And then you substitute. You see right over here, there is tangent squared theta plus 1, right? So how we can simplify? We just recall back to the trigonometry identity. So tangent squared theta plus 1 is equal to secant squared theta, right? So you just substitute the value of tangent squared theta plus 1 to make it simplified, to make it simple, to make it easy. Okay, you just substitute it. Tangent squared theta plus 1 become 64 times secant cube theta. After you multiply the secant squared theta with the power of 3 over 2, you just cut it off and it will be 64 times secant cube theta. Okay, then you substitute the value of dx for secant squared theta d theta and cube root 16 plus x squared to equal to 64 times secant cube theta into the expression. Okay, where you get the dx and the 64. Okay, 64 times secant cube theta is from here. You have find it just now, and dx, we call it back. Okay, dx from the indefinite integral of x. Okay, dx for secant squared theta d theta, and you transfer the value into this into this expression. Okay, you transfer the value, and then okay, 1 dx is 4 secant squared theta d theta, right? So this cube root will be 64 secant cube theta. 64 times secant cube theta. And then 4 divided by 64 is 1 over 16. And then you cut secant squared over secant cube, it will just secant theta. Just put out the 1 over 16 into the outside of the integral so that it make you easy to integrate it. And then just integrate it normally. But remember, you have to use the trigonometry if you see there is trigonometry value there. So integrate of d theta over secant theta is cos theta. And then integrate of cos theta become sin theta. So 1 over 16 theta sin theta plus c. Okay, then after we get the value, after we get the integrate, uh, we can transfer it into the right angle triangle. So since we let x equal to 4 tangent theta, we can use the Pythagorean theorem expression for sine. As we know, tangent theta, tangent is opposite over adjacent. So tangent theta x over 4. From the triangle, we can also find the value of sine theta, which is as you can see right over here, sine theta is x over square root of x squared plus 4 squared, because sine theta, sine opposite over hypotenuse, which is x over square root of x squared plus 4 squared. Therefore, you will get integral of 1 over 4 squared plus x squared to the power of 3 over 2 dx, becoming like this. Okay, 1 over 16 sine theta plus c, 1 over 16 sine theta plus c, you just found right now this value. And then you substitute the value of sine theta with this value, x over square root of x2 plus 4 squared, and then plus c. Just multiply it normally and the final answer will be x over 16 times square root of x squared plus 16 plus c. Okay. I will pass this lesson to my friends. Thank you.
Okay. Okay, right now we proceed with example 3. Okay, for example 3, okay, the question is integrate dx over square root 4x squared minus 1. Okay, we integrate this by the factoring the denominator. Okay, so it will become integrate dx over 2 square root x squared minus 1 over 4. And then for to determine whether we want to use the to determine whether the substitution of trigonometry that we want to use is by looking at the denominator. For example, this question is x squared minus a squared. This this form of question, we will be use tangent as a secant theta. Okay, for determine the a values. For first, we a squared minus 1 over 4, and then we get a equal to 1 over 2. And then for this, from this value, we can say that x equal to a secant theta, which means x equal to 1 over 2, the a value that we got, secant theta. So we get 2x equal to secant theta. And then we have to find the dx value, which means 1 over 2 secant theta tangent theta d theta. How we got the value is we just copy back the x value and integrate the 1 and integrate the secant theta, and then we got 1 over 2 secant theta tangent theta d theta. Okay, since to add secant theta, and then since 2x equal to secant theta, and then we know that we have to use the reference triangle. For use the reference triangle, we have to use Socha-Toa, which means in this question, secant theta is equal to 1 over cos theta. However, in this question, we got that value, we want to find the value of secant theta. So, secant theta equal to hypotenuse over adjacent. Okay, by use the Pythagorean theorem, a squared plus b squared minus c squared. Okay, can you see the triangle?
Yes.
Can you hear my voice? Okay. Okay. For looking the right side of right angle, we have to use the Pythagorean theorem. A squared plus a squared, which is adjacent. A squared A square is the opposite. Excuse me. A square is the opposite plus b squared, which is hypotenuse, which is adjacent, minus equal to c squared, which mean hypotenuse. Okay, 2x squared. So we got a squared plus 1 equal to 4x squared. We got a squared minus 4x squared, value of a, which means square root 4x squared minus 1. Okay, this is defined as tangent theta. Why tangent theta? Because we know that tangent theta is opposite over adjacent. So opposite value is square root 4x squared minus 1 over adjacent, which means 1. So okay, next from the values that we got, we substitute back trigonometry into the integral given. Integrate ds over square root 4x squared minus 1 equal to, we substitute back, integrate 1 over 2 secant theta tangent theta d theta, which is the value of dx, over 2 tangent theta that we got, square 4x squared minus 1. Okay, we got 1 over 2 integrate secant theta, excuse me, we integrate 1 over 2 secant theta tangent theta d theta over tangent theta. We got 1 over 2 integrate secant theta d theta, and the answer is 1 over 2 ln secant theta plus tangent theta plus c. Okay, the answer, so we substitute back the trigonometric values to in the form of s, 1 over 2 ln the bracket to, what we call the bracket. Does anyone know? Hello, can you hear me? Ln, okay, 1 over 2 ln bracket to x plus square root 4x squared minus 1 plus c. So this is the final answer. Okay.
Okay, so I will proceed to the next lesson. My name is Afida. So, what about the previous lesson? Do you understand what trigonometry substitution about?
Yes.
Okay, so for my part, we can do some activities so you will more clear about how to do trigo in solving problem, how to do trigo in the questions. Okay, so let's start. Okay, can you see my slide? Hello, can you see my slide?
Yes.
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 Good. Okay, let's warm up. Okay, after the long explanation, so I will make a few brief explanation about how trigo substitution, trigo substitution. So this is a few steps that I make. This is a summary of how to do the trigo substitution. Okay, the first step is you have to identify. So my previous friends, you have to know trigonometric expression. So if you got the question, firstly, you have to identify which trigonometric expression you will use. So, for example, for this question, you can see the question asks about square root 81 minus 8 square. So based on this question, you have to find which trigo expression we will use. For this, you will use the first one, which is x equal to a sine t or x equal to a sine theta. So after you identify, you will use some substitution to find the value of x, to find the value of dx, and to find the value of a. So based on this question, you've already find the value of a, which is 9. Okay, this is the first step. So the next step, you will integrate. In this step, you will substitute. You will make a simple substitution to get the answer. It's not the final answer yet, but the answer. So for this example, you will do some. You in this part, you have a long solution, because in this part you will use trigonometry expression. You will use trigonometry identity. You will substitute to get the answer like this. So the third step is to draw a triangle. So this you must to draw a triangle, because some student they forgot to draw the triangle, so they miss this step and they get wrong. So the third step, you have to use the triangle. For example, this like the previous session, you have to use Pythagoras theorem to solve this, to find the value of a, to find the value of b, and to find the value of c by using the equation c square equal to a square plus b square, right? So the fourth step, the last step, is to simplify. So to get the final answer, you have to simplify uh, the the equation, uh, and you will get the final integral. So that's all the four step. You cannot miss this fourth step, because you might get wrong to get the final. You might get hard to get the final answer. So, okay, are you ready? We are going to play some activity for you to be more understand in this chapter. So are you ready?
Yes.
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 Uh, okay, find your partner. We have 30 members in this group, right? So I want to you find your partner. In 10 minutes, work in a pair. Answer the following question. I will show you the question after this. So, but first, please open this Padlet, because you will capture your answer and paste in this Padlet, so we can share it to your friends. Okay, here I provide you some trigonometry identities. In case you don't know how, in case you don't remember the trigo identities. Okay, here the first questions. Work in pair and answer this question using trigonometry identities. I give you 10 minutes. Let me know if you're done. Okay, let me check if any of you have already answered. Okay, this is the question.
Okay.
Okay, I think we have already few answer. Let me see. Oh, it's from Nurul Ashikin. Okay, let's see the first question first. Okay, from Nurul Ashikin. Okay, firstly, she did identify. Okay, she know. Okay, she find the value of A. Okay, okay, she used tan as written because this is the symbol of plus x squared plus x squared. Okay, next, she substitute the value. Okay, okay, correct. Okay, so the second step, you have to integrate. Okay, she lets you. Okay, good. Okay, so is this the answer you sent, Ashikin? Okay, the Ashikin answer is good, but not complete. She already stopped here. So most of the student will stop over here and think this is the final answer. This is the big mistake that every student makes. Not all student makes. Not all, but some people, some students. So actually, this is not the final answer. You have two more steps to do to get the final answer. You have to draw a triangle, and after that, you have to make some simple simple substitution to get the final answer. So Ashiki, make sure you don't repeat this mistake, okay? Okay, so we have next answer from Farizan. Let's see Farizan answer. Okay, Farizan 2 a square plus x square. Okay, Farizan did the first step. She find the value of a. She do substitution. Okay, correct. Okay, same answer like Ashikin just now. Okay, so the next, she do some integrand, and also this so this is this the final answer, Farizan, or do you have any more answer?
No, not yet. Loading.
Oh, you not yet. Okay, we see. Wait. So while waiting for Farizan answer, okay, Ashiki, look here. So do not miss the third and fourth step. Okay, if you miss this, then you will get the wrong answer. So make sure you follow the step by step. Okay. So Farizan, let me know if you're done. Okay. Okay, we have another answer from. Is it from you, Farizan? Okay, I guess this is from Farizan. Okay, so look, Farizan do a third step, which is she draw a triangle to find the value of A, B, and C. So by using this trigonometric expression, she find the value of C, which is the value of C is x squared plus 9. So after find this value, she did some substitution here. And the last step is she going to make a integrate. She make a sum substitution to find the final answer. Okay, so this is the final answer. This answer is the final answer that we want. So for student like Ashiki, please double check your answer before submit. Okay. So this is the final answer. So it is correct. Okay. Thank you, Farizan. I have one more question, but since we don't have enough time, so we can do the second question. Okay, this is my answer. My answer is first you have to identify the question and substitute the express trigonometry, and then you integrate, and the next is you draw a triangle, and the last step is simplify until you get the final answer. So my answer is same as Farizan just now. So Farizan is correct. So this is the question 2. You can do it at home. I will provide you questions you can see and the answer. So this is the question 2. So that's all. Congratulations for those who are answered the question correct. And congratulations.
Okay, Miss. Sorry, Miss.
Yes.
Can I print screen your question too just now
Okay, yes, you may.
and the answer? Okay, thank you. Question two. With the answer, can I?
Oh, with the answer, yes?
Right. Okay, done. Okay. Okay.
You have to write, this is the third and fourth step.
Okay, done.
Okay, done. Okay, thank you.
Okay, we continue. Okay, we continue with our last assessment, which is we use Kahoot. Can you see my screen?
Not yet.
Loading.
Can you see?
Not yet.
Okay.
Okay. Can.
Uh, please open the Kahoot. I give you 5 questions. Just a simple question to remember back the lesson that we proceed before this. It's better to you give your real name. I will take a result from your score playing Kahoot. Can we start?
Yes.
Can.
Start. Choose the correct answer by using Pythagoras theorem. I give you a lot of time to calculate your answer by using Pythagoras theorem. All of you remember that Pythagoras theorem a squared plus b squared equal to 3 squared. But
Yes.
you all answer, all of you? One more, one person. You got your answer?
200.
Yes. Okay, Vicky. Good. Only one false. Actually, in the first row. Okay, next. True, false. True or false question. Okay, we see. Next, a chicken. Yes, a chicken again. Next question. From the question given, we use oh, so fast, huh? You all answer so fast. Okay, we skip. Next. Wow, Afida. Okay, next. Second last question. Should the true answer for this question tan sin cos sin cos plus cos x equal to z? I give you a lot of time to calculate. Answer your question in the paper. Two-person for another three answer. Okay, take your time. Okay, you all understand the answer, the question given. Next, last question, which is true or false statement. Is it true? Looking carefully the sign. Okay, true. All of you is true. Give a true answer. We see the winner. Oh, Afida. Okay, that's all for the assessment. Kahoot.
Okay. For conclusion, before the lesson, I can say that a lot of you understand know about the concept, but does not memorize. But you don't have you don't remember what is Pythagorean theorem and and trigonometry entities. During the lesson, we explain the lecture and we explain to you what is trigonometry identities, the Pythagorean theorem, and how to use the Pythagorean theorem to find the right side of the triangle. And after the lesson, I can say that a lot of you actually must master the question and you can answer for out of 7 questions true in Kahoot and also in Padlet. So I can say that all of you understand about this topic. Okay, that's all. Is any one of you want to add reflection?
Uh, can I answer? Can I give some reflection?
Yes, can.
Okay, after this lesson, I'll be more. I know more how to do trigo substitution. I I know how to do it with a few simple steps from the lecture given. So it might easier for me to use in the examination later on.
All right. Thank you for your reflection. Is there anyone to add your reflection?
Sorry, Miss, may I tell my
Yes.
reflection to you?
Okay. All right. You may.
Okay, can I try? Okay,
Okay.
my reflection towards this subtopic, which is trigonometric substitution, I think at the end of this lesson, I can choose which is how to use trigonometric substitution, whether sine substitution, tangent substitution, or secant substitution. And then I can replace the value of x and the x value with theta and d theta, and then uh, I also can use I also know how to back substitution to put integrated value back in terms of x instead of theta. Okay. Is it true?
All right. Good.
Okay.
Yes. Thank
Thank
you.
you. Welcome.
Okay. So I guess our lesson just finished. That's all from us now. Thank you.
Thank you.
Thank you, Miss.
Yes.
Thank you, Miss.
Welcome.